In previous lesson, we calculated the sum vector, the r vector. So r vector makes the x component square and the y component square. It nearly 125. So we can say for it 5√5 in newtons. So about the subtracting, for example, we have same set for a and b vectors, but now we will find the difference between these vectors. We can make it like this mathematic way. Because of that, a minus b equals at the same time a plus minus b. This is easier because of that a minus b is not a good operation for vectors, but a plus minus b is an easier way to finding this subtracting. So now we must find the minus b. If we have a vector like this, like b, for finding minus b, we must inverse it. We talked about the direction axis for the vectors. For example, southwest to northeast or northwest to southeast. As you can see, our vector b is on the northwest southeast direction axis. So if we inverse it, we must change its direction to the another side, to the negative side. So if we make this progress like this, plus minus b, we can easily find the solution. A and minus b. So our sum vector is starting with the same starting point with a and ending with the same ending point minus b. So it makes r again. You can write down in your notes like this. Or like this. Because if you multiply plus sign to minus sign, you can get minus sign. This is the same values. For separating side of this method, you can use, for example, a plus minus b equals ax plus ay plus negative or minus bx and minus by. So it makes ax minus bx plus ay minus by max again. We don't use the vector multiplication in our workings. So the dot product or cross product not in our cell labs. Now we can talk about the unit conversations. We are using the conversation because of that. In physics, we can work in the smallest or the biggest particles, like universe is a biggest thing for physics, or atom, the smallest are for the physics. So we must measure it with what, for example, a matter, for example, a gram. So for making this, we are using the metric system. In the metric system, we have powers of 10, and also we have their prefixes. For example, for the metric system, we can use 0th power of 10. It makes our base. We can say for base, for example, matter. Because of that, 0 to the power of 10 makes 1. 1 matter is a base point for us. So we can go up or we can go down with our decimals. For example, 1, 2, 3, 6, 9, 12. For the going down, we can use a minus sign, -3, -6, -9, -12. But for indication of this, we must use some prefixes. What about the prefix? For example, -1 makes centi, no centi, makes deci, makes centi, milli, and micro, and nano, and pico. For going up, deca, and hecta, kilo, mega, giga, and finally tera we are using. For example, deca, meter, hecta, meter, and kilo, meter. For the another ones, decimeter, centimeter, millimeter, micrometer, nanometer, and picometer. But how we can symbolize it? For example, decameter, like this, or hectameter, or kilometer, megameter, gigameter, and terameter for meters. For the inverse of this, we can say decimeter, centimeter, millimeter, micro with a letter mu, and nanometer, and finally picometer, let's see. Maybe in some atomic lengths we can say femtometer. Because of that, 0.5 femtometer makes the radius of an atom. So we can convert them to each other because of that. For example, 1 kilometer equals how many micrometer we can say. For the easiest way, I can say you must write down the mathematical values of the prefixes. For example, 1 kilo makes third power of 10, so it makes matter again. And also we know for the micrometer is -6. If we want to convert it, we can say divide with other prefix. Because of that, we know that 1 kilometer equals how many micrometer? We will go with micro. So if we divide it with micro prefix, we can find the ninth power of 10. So it makes for us, for example, you can use it like 1,000 gram. 1,000 gram makes 1 kilogram, or 1,000 meter makes 1 kilometer, or the inverse of them. 1,000 kilogram equals 1 times 6 power of 10 grams. You can drive it, and some quantities we know constantly. For example, a mile. For 1 mile, we can say 1,609 meters, or 1 mile makes 1.609 kilometers, or 1 feet makes 3.28 meters, or for 1 meter you can say 1 divided by 3.28 feet. But I will look again for the feet conversation. Yes, it's not true. 1 feet equals 0.305 or 0.48 meters. But don't worry about it, because if they ask it to you in the questions, they will give the conversation table to you. Şöyle Nil, orada kilogram to gram ama 1000 kilogram olduğu için bir 10 üzeri 3 de oradan eklendi. 1 kilogram olsa 10 üzeri 3 gram olacaktı. 1000 kilogram olduğu için 10 üzeri 6 gram oldu. Now we will look for good conversations. Because of that, in questions, they are asking to us. For example, in motion questions, they are giving mile to hour to kilometer per hour. So one more we can choose kilometer per hour to meter per seconds. So we know that 1 mile equals 1.609 kilometers. So, for example, 10 mile per hour to kilometer hour, they can ask to us. So we can say 10, it's okay now. But for mile, we must write 1.609 kilometers, and we can write down the hour again because we are converting hour to hour. It doesn't matter for us. So it makes, if we multiply them, 16.09 kilometer per hour equals 10 mile per hour for us. But in questions, in generally, we can see kilometer per hour to meter per second because it's a harder from the mile per hour to kilometer per hour. So, for example, they can give 36 kilometer per hour and convert it to meter per seconds. So, firstly, we must write down meter against kilometer, and we know that 1 kilometer equals 1000 meter, so we can write 1000 meter, and for the 1 hour we can say in 1 hour we have 60 minutes, in each minutes we have 6 seconds, 60 seconds, so it makes 3600 seconds. So if we making cancellations, these zeros cancel out, and also this 36 cancel out. It makes 10 meter per second. So we can say 36 kilometer per hour makes 10 meter per second in SI unit system. Or you can derive it like this. For the 18, it makes 5. For the 72, it makes 20. You can notate it like this. You can use them correctly because in your exam the calculators is not allowed, so they will give the constant ratio to you. For example, 36, for example, 72, like this. So you can easily convert them to each other. For the last part, for our first unit, we will mention about dimensional analysis. Dimensional analysis is important for us because of that we made some conversions in the upper side of this page. So for dimensional analysis, we can say if you use the equation, if you use the equal symbol, the left side and the right side must be in same units. For example, kilometer per hour is not equal to meter per seconds. You must find meter per seconds equals meter per seconds, or meters equals meters. So, for example, you are using a formula. A formula is x equal 1 divided by 2 a and t squared. This is the correct formula. We will find the dimensional analysis of it, but we will write down a not correct formula. For example, x equals 1 divided by 2 a times t. Not correct. How can we find is it correct or not correct? We can find making dimensional analysis because of that. X, distance in meters, 1 divided by 2 is a constant number. So the constant numbers have not units. So This is unitless for us. We will not use the numbers in unit dimension or units dimensional analysis. So A is meter per second square for the acceleration. And finally, the time or the time gap in second square again. When the second squares cancel out, we can find meter equals meter. It's okay for us. But for the wrong formula, we will see meter equals meter per second square times seconds. So when we cancel the seconds, we find meter equals meter per second. It is not equal because of that. If the left side is true, it will be meter. If the right side is true, it will be meter per second. So you can easily find out which formula is true and which formula is wrong for your calculations or your workings. Dimensional analysis using for them. Now we can speak about real physics. The real physics starts with motion. But firstly, we must learn the motion variables. What is the motion variables? For example, distance, displacement, speed, velocity, and finally, acceleration. And its formulas and its graphs we will find. Now, the distance and the displacement, they are different. Because why? We mentioned before about vectors, and we will work on vectors again. Because of that, displacement is a vectorial quantity and distance is a scalar quantity. Now, I will draw a vector and I will draw the components of this vector. So, think like that. You are starting from your home and going to your school. And you can use two different ways. One of them, the red road, and second of them, the black road. If you use these roads, what is your distance and what is your displacement? We will answer these questions. And I will say 3 kilometer, 4 kilometer, and 5 kilometer for the hypotenuse. So if you use the red road, you will go the right side and you will go the positive y-axis. So totally you covered 7 kilometers with your foot. So your distance is 7 kilometers because you walk this way. But your displacement is the smallest length of the 2 points from to home to school is point A, is point B, and the smallest length between points A and point B makes 5 kilometers. So your displacement is 5 kilometers. So distance and displacement, different things. One of them covering and Displacement is the smallest way, we can say easily. You can see this question roots in your questions, I think. But if you use another way, this hypotenuse, your distance and your displacement will be same, but not in every time they are equal. Sometimes they can be equal, but we cannot say it for the all times. So for the distance, we can say scalar and displacement is vector of distance in matters, displacement also in matters. For speed and velocity, we can say same things. Speed is scalar quantity and velocity is vector quantity. Speed in meter per seconds, velocity in meter per seconds. Speed indicates with this symbol and velocity indicates with vector cap of the symbol. For the formulas, we can say V equals total distance divided by total time. For the velocity, we can say total displacement divided by total time. You must memorize it. Displacement for velocity, distance for speed in our usings. So what about the acceleration? Acceleration, the change rate in velocity, not in speed. So we can say about acceleration, this is a vectoral quantity. For the symbol, we are using a vector, and for the formula, delta v divided by delta t. Delta v equals change in velocity, and delta t equals the time gap between starting and finishing. So we can say v final minus v initial divided by t final minus t initial for this formula. And this makes an increase or decrease in velocity. If the velocity increase, we can say speeding up, and velocity decrease, we can say slowing down for these particles. For example, you have a running competition and you are starting from a point, also you are finishing at this point. So the circle has a 400 meter length and you are covering this you are covering this circle with 10 seconds. What about your speed, and what about your velocity, and what about your acceleration? First of them, we can find the speed. Because of that, we know the total distance covered with running. So V equals 400 meter divided by 10 seconds. It makes 40 meter per second. For velocity, our starting is x initial equals 0, but finishing at the same point, it's also x equals 0. So the total displacement is 0. Also, our velocity is 0 meter per second. So our velocity is not change. Because of that, we are running on a circular path. So our acceleration will be 0 again. So I will say another thing about the acceleration. Acceleration in meter per second square, about looking the units. So we can say clearly distance and displacement is different things. Also, the speed and velocity is different things. But distance, we can use distance in speed calculations. Displacement, displacement is using for velocity calculations. When we look the acceleration, acceleration using for the changing velocity in changing time. Then in the next lesson, we will see about the motions and their graphs. Merkezcil ivmeye daha var. Oraya daha gelmedik. Biz şu an lineer kısımdayız. We will see in third lesson. Goodbye.